This is Max Donath. Welcome to the Transportation Safety Webinar Series, Moving Research into Practice. This webinar series, jointly hosted by the Roadway Safety Institute at the University of Minnesota and the Midwest Transportation Center at Iowa State University, highlights innovative transportation research. Webinars will share the impacts of research conducted through both of these regional university transportation centers. You'll hear from both researchers leading the work and practitioners implementing results in the field. A recording of this webinar will be available on the Roadway Safety Institute and Midwest Transportation Center websites. Today, we will hear from John Hourdos and Joe Gustafson on the topic, Evaluation of Safety and Mobility of Two-Lane Roundabouts. I'd like to introduce our speakers before they get started. John Hourdos is the director of the Minnesota Traffic Observatory and research associate professor in the Department of Civil, Environmental, and Geoengineering at the University of Minnesota. His research interests are traffic simulation and model calibration, as well as traffic safety, focusing on analysis and crash prevention. Joe Gustafson serves as the traffic engineer for Washington County, Minnesota, where he has worked since 2008. Gustafson is a registered professional engineer in the state of Minnesota and holds certification as a professional traffic operations engineer. He currently serves on the Minnesota Committee on Uniform Traffic Control Devices and as a county representative on the Minnesota Department of Transportation's Roundabout Steering Committee. Now, I'll turn it over to Joe.
Thank you, Professor Donath. I hope everybody can hear me okay. This technology is a little bit new to me, but if you have any problems, by all means, type them into the box. So I will start. Hopefully I can advance the slide here. I'm not sure how many attendees we have from outside Minnesota, but in case we do, just a little bit about Washington County. We're located on the east side of the Twin Cities metro area. Our population is about 250,000, and we currently have 13 roundabouts on our county roads, or at intersections with our county roads. 10 of them are single lane, 3 are multi-lane, and as is usually the case, we do have more on the way. We have 2 planned for this upcoming year. So what I will cover today is a little bit of history of roundabouts within Washington County, and in particular the multi-lane roundabout, and what did not go so well with those. I'll talk about some treatments that we have implemented as far as signing, striping, delineation, and also a roundabout diet lane reduction. And I will end with future areas of interest and for research. And in the midst of this presentation, I will turn over to Professor Hourdos, who can talk a little bit about some of these research initiatives. So a little bit of history, timeline of roundabouts within Washington County. In 2007, the county opened its first roundabout on our county road system. That roundabout was our full 2x2 multi-lane roundabout. We followed that in 2008, opening 3 single-lane roundabouts, all within the same corridor. In 2010, there were 2 MnDOT roundabouts that opened up to traffic within the county that were at intersections with our county roads. For anyone outside the state of Minnesota, when you see the acronym CASA, that's County State Aid Highway, that's essentially a county road that receives state gas tax money. In 2013, we opened 6 more roundabouts along our county roads, 3 of which were owned by the Minnesota Department of Transportation, 3 of which were owned by the county, but all involved county road intersections. In 2013, there were 2 roundabout diets completed within the county, and I'll talk about those later in my presentation. And coming up this year, as I mentioned, we have 2 more roundabouts planned. One is multi-lane, the other one is a single lane, plus an additional right turn lane on one approach. So the first roundabout that we opened was in 2007 on Radio Drive in the city of Woodbury. This is a picture of the project location before construction. It had been a always stop, single lane approach from all directions, plus an additional right turn lane. Got pretty congested during peak hours. The north-south roadway through here, particularly to the north, was on deck to be widened to a 4-lane divided road. The roundabout was constructed, and this picture is at the same scale as the previous one that you saw. You can see it has 2 lanes of approach, 2 through lanes in particular, from all directions. What you don't see in this picture is as you go off to the left and the right of the picture, the road did drop back down to that 2-lane rural highway design, but this did continue as a 4-lane divided road up to the north. And so I'll actually jump back and forth just so you can get a sense of the scale of the roundabout relative to the old all-way stop condition. And it did solve the traffic flow problems. Definitely the queuing went away, the delays went away, but it was averaging 40 crashes per year, which was very alarming. By and large, they were certainly all very minor crashes, low speed, low impact, but certainly from a public relations perspective, as far as wanting to implement more roundabouts to help promote traffic safety, this was really a problem and something that we had to address. The roundabout on its opening day, this was late in the season in 2007. This was before the wear course was applied. That did not go on until the following year. And so you can see the striping is a little bit haphazard, but generally had all the major features of a multi-lane roundabout. And from the get-go, one of the problems that we were picking up on with these crashes was just a few miles to the north within a shopping center was this contraption. And so you can see there's this circular road. You can see a semi-truck making a turn out of it. And this was yield controlled for traffic that was entering it from the east. And to a lot of drivers, you know, this was probably their greatest familiarity with multi-lane circular types of intersections. As time went on, we realized that really, you know, this was not our boogeyman. We really had a much larger issue to contend with as far as driver perception. But this was certainly something that jumped out in conversations early on. And so what it quickly distilled down to was there's really 2 basic flavors of intersections that feature circular center islands. The first one, which we had constructed on our county road, is a modern roundabout. And for the purpose of this presentation, I will say that a modern roundabout is an intersection at which left turns are made by the far side of a central island. As opposed to a standard intersection that does not have that central island, those left turns would pass on the near side of each other rather than on the far side. This is not to be confused with a traffic circle, which is a junction consisting of a set of T intersections with a circular road. As you saw in that shopping center picture, there was a circular road that continued in a essentially endless loop. I'll highlight some of the differences here and why that's important. And it's important because especially when you start to get multiple lanes involved, the legal operations and the proper driver behavior that we expect are very different at these 2. At single lane configurations, that can kind of be safely ignored, but in multi-lane condition, this is certainly a problem. And so to give an example of that, our most common crash type, you can see our modern roundabout on the left and that circle road up at the shopping center on the right. Both have 2 lanes of approach, both have yield control, and even though one's much larger, conceptually they look pretty similar to drivers. And you can see that in the picture on the right at the traffic circle, that driver is that's entering via the right-hand lane really has no problem entering alongside cross traffic that's on the inner lane of that traffic circle. But when you look at the picture on the left, you can see if that driver does the same thing at a modern roundabout, there will be a collision. And that's definitely the most common crash type that we were seeing. Less common crash type, but still a significant one, is this issue of the fact that at a roundabout, the lanes lead out of the intersection. Whereas at a traffic circle, since it's a series of T intersections, drivers need to make a right turn to exit. So in these 2 pictures, I'm not showing the crash type, but you can see in the picture at the right, it's just fine and dandy for somebody to continue to circulate around the intersection in that outside lane. If somebody had done that at the roundabout, they would have collided with the vehicle that was immediately to their left. Likewise, at the traffic signal on the right-hand side, that inside lane has difficulty exiting. They essentially get trapped by the traffic that's in that outer lane. That's something that would never happen at a roundabout. But to take circular type intersections just out of the equation, and like I said, we at first thought that the shopping center traffic circle was our boogeyman, but really it was much larger than that. It really came down to what drivers encounter at any multi-lane intersection. And this image here is from a report out of Canada that was provided to us by Dakota County. It originally came from the regional municipality of Waterloo, Ontario, and one of their consultants. And what it shows at the bottom is typical driver behavior at a multi-lane right turn condition. And you can see when the vehicle in the blue in the bottom of the picture comes up to make that right-hand turn, they really have very little need to be concerned with traffic in that left-hand lane. And they can make that right turn without consequence. But the problem is drivers are trying to apply that same logic to a roundabout. And the issue is, in the bottom, the driver in the blue is making a right turn. At the top, the driver is making a crossing movement. And really what the problem boiled down to was drivers were perceiving that roundabout entry as a right turn when actually it was a crossing movement. And that's when we realized that that was the root of our issue. How do we communicate that effectively to drivers? So what does this all boil down to? Like, as I pointed out, a modern roundabout is not a series of T intersections. There is no circle road or a circulatory lane at a modern roundabout because the lanes lead out of the intersection. And the crash issues that we were seeing is because drivers would come up to the roundabout. They were expecting a certain type of configuration, that being a circle road. And what they were encountering was something different, but the design of the roundabout, the signing and the striping weren't enough to help them recognize the difference between those two configurations. That was the root cause of all the crash issues that we were seeing. It became very apparent by reviewing all the crash information, the statements by the drivers in those crash reports. And so the types of crashes that we were seeing, by and large, were these two. We had a handful of rear ends, but generally by about a 3-to-1 margin, the fail to yield crash was our most common crash type. It was never an issue that the driver wasn't seeing the yield sign. It was never an issue, from what we could tell, that the driver wasn't seeing the other vehicle. The issue was they thought it was okay for them to enter alongside that vehicle, as would be the case at a multi-lane right turn. But again, as we tried to highlight in these pictures, which are slightly exaggerated, is that driver that's making that movement is making a crossing movement, not a right turn. As I mentioned, our less common crash type, but still a significant one, is what we termed the fail to exit crash. This is when a driver attempts to circulate, essentially, in that outer lane, but what they're really doing is making a left turn from a right-hand lane where that is not allowed. And so again, if this were a series of T intersections, that would be absolutely acceptable. That's certainly the case up at the shopping center, but it was never the case at the roundabout, and we certainly saw some crashes that were resulting from that. So the crash issues that we were seeing were pretty significant in number. We were tracking them quarterly, and so what you can see is it varied a little bit, but generally about 9 to 12 crashes per quarter. And the pink line that you see is those fail to yield crashes. The blue line, which is the lower one, is that fail to exit crash, that improper lane use when somebody tried to make that illegal left turn. And then the yellow line is ones where there just wasn't enough information in the crash report to determine it. But in most cases, it seemed like it was one of those two. And again, I would assume that about 3/4 of those were the failed to yield type. So we certainly realized we had a problem here. There was a roundabout that opened in Richfield that was experiencing very similar issues, identical geometric configuration to ours. So certainly a research project that we took a great amount of interest in, and certainly posed some challenges as far as data collection. So with that, I will turn it over to Professor Hourdos, who can talk about those data collection efforts.
Hello, everybody. As Joe said, the another roundabout in the metro area of the Twin Cities was the one on Portland and 66th Street in Richfield, Minnesota, which is a suburb right attached to the city of Minneapolis. Joe did a very good job describing the crashes, and certainly these type of crashes were observed in the Richfield roundabout after 2008, where it was converted from a signalized intersection that was the third worst in Hennepin County in terms of crash severity and cost of crashes. But in the first 3 years of the operation of the 2x2 roundabout, there were 90 reported crashes. All of them were minor crashes, property damage only, but still a very big concern for the people. In this case, the traffic demand does not allow any lane reductions, is what Joe is going to explain later as a roundabout diet. So other solutions had to be investigated, since the combined ADT around was 30,000 vehicles. Now, if you can see some of the videos here that we collected during our research, you'll see exactly the videos, exactly the types of crashes that Joe showed. So on the right-hand side of the video that is playing, you will see that one vehicle from the outside lane is trying to make a left turn and collides with the van that wanted to exit the roundabout. On the other video, on the right-hand side top, that you'll see a failure to yield, where the vehicle thought that the vehicle inside would keep going around, but instead wanted to exit. So the next slide basically shows a rather long list of things that we decided to change in the roundabout and in an attempt to fix the problem. I'm going to go to the next slide instead of reading all this, which is more revealing of the things that changed. So in terms of pavement markings, the turn arrows on the approaches to the roundabout and inside the roundabout were changed from the fish hook style to the standard side, because some people basically have the opinion that people are unfamiliar with the fish hook sign. It gives you the sense of circulating, so the regular straight arrow signs would be better. Additional turn arrows and lane designation signs were placed approximately 450 feet upstream of the approach. The solid lane, as you notice, the solid lane line that was extended, originally it was approximately about 50 feet upstream of the yield line. In the new design, this solid line is extended 250 feet upstream. This line was extended in order to enforce the message to the drivers that they need to select the appropriate lane before they reach the entrance to the roundabout. In terms of lane markings, we also eliminated the solid, then skips in the circulatory roadway and changed to consistent line gap sequence of 6 feet line segments and with a 3 feet gap. In terms of signing, the yield signs at the entrance and the pedestrian crossing signs were all lowered, so the line of sight is not obstructed as the vehicles are waiting on the yield line. And there was an additional, because we have, in a previous study, we have noticed that there is a very low yield rate to pedestrians on this roundabout. Additional crosswalk signs were replaced with the R61 paddle signs on the islands before the crossings. Now, we designed our own video collection system. Basically, we deployed in the middle of the roundabout island, a 38-foot extendable mast trailer, which we covered with a green tarp so it doesn't become an eyesore. And on that, we put a 360-degree camera, as you can see on the screenshot, which allows us to see the entire, collect video of the entire roundabout in one frame. The types of data that we extracted manually in that project was for every vehicle that was using the roundabout, the time of entry, the vehicle type, the entrance lane, the type of violation that this vehicle performed, and there's a list of 13 violations that vehicles can perform in a roundabout, like the ones that Joe described, in addition to changing lanes in the middle of the roundabout, straddling the lane, and so. And we also recorded the correctness of the entrance lane choice, depending on where the vehicle finally wanted to end up. Now, our before and after study happened in two stages. We collected video on the before, which was before any of the changes took place, and we collected video approximately 3 months later. And then we repeated the data collection 1 year after that, because we wanted to see if the changes had were persistent. So specifically in terms of the yield violations, although in the immediate before-after condition, we saw a slight reduction in yield violations. Unfortunately, this was not sustained over the year after, and in which case we actually noticed a 30% increase in yield violations. Now, in terms of lane changes, which they only generate a few crashes and very minor crashes, but still there are violations, immediately we saw a 20% decrease on these violations, and that decrease was sustained a year after. That wasn't my phone.
Sorry, that was mine. I had it off the hook. I don't know how it rang.
In terms of 10 violations, that was where we saw the biggest reduction. Immediately after the implementation of the changes, we saw a 48% reduction in 10 violations, which carried over a year after at a 44% level. Specifically, the left from the outer lane violations were reduced by almost 50%, and that reduction carried over a year after, which led us to believe that the solutions that we implemented were effective and permanent. Now, one clue that because we did a lot of changes at the same time, one clue that basically led us to believe that the additional signs, probably the change of the fishhook signs to the straight, and the extension of the solid line at the entrance, is that at the same time that we saw the reduction in violations, we also saw a similar reduction in selecting the incorrect lane for the destination. So you see that immediately we saw a 53% reduction in selecting an incorrect lane choice, which also sustained to about 50% after a year after. So the conclusions from our Richfield experiment was that the changes in the signs and lane markings of the roundabout had an effect. Unfortunately, the yield violations did not show any improvement, so we haven't found a solution for that. But in terms of the lane change violations, showed a moderate improvement, approximately 20%, and we can attribute this reduction to the lane marking changes inside the roundabout. Now, the turn violations showed the biggest improvement, with the most severe of them reduced by 45%. Considering that the incorrect lane choice instances also were reduced by 50%, we can basically lead us to attribute this improvement to the solid line extension from 50 feet to 250 feet and the additional lane designation signs. So, following that project, and since that was only one roundabout, we had to extend our investigation to more roundabouts with different designs and different types of driving population in order to basically solidify our ideas about what can be done to multi-lane roundabouts to improve the safety. So for the current project, which is currently ongoing, we selected, we were going to select a minimum of 3 additional roundabouts. We ended up with 4. One of them is on the University Drive and 5th Avenue South intersection in St. Cloud, Minnesota. 2 of them are on Highway 22 in Mankato, crossing Adams Street and Madison Avenue. And a brand new one, which opened last summer in Lakeville in the intersection of 185th Street and Kenwood Trail. So these roundabouts vary greatly in terms of the built environment, the driving population, and especially the age of the roundabout. The goal of our project is to basically solidify our understanding of what are the solutions in terms of lane markings and signs that work, so we can provide a guidance for Minnesota County and municipal engineers. Now, in the St. Cloud intersection roundabout, there's 3 approaches of interest. There's only 2 2x2 approaches. So we deployed 2 cameras and collected for 2 weeks, in addition to looking at the crash history. Now we're proposing implementing extending of the solid stripes on the approaches and putting additional signs. We're working with St. Cloud to see if this is going to happen in the concept of this project. Now, the latest roundabout is the one in Lakeville, and you see here a bird's eye view of it. It is brand new, and immediately after it opened, there was panic because of all the crashes that were taking place. There were 7 crashes the first week of the roundabout opening. So now one difference, because this roundabout, the one in Lakeville, implemented some of the guidances that we provided from Richfield. So they did use the straight arrows instead of the fishhook arrows, as you can see here. And they also extended the solid line not to 250 feet, but 100 feet from the yield line. In addition to in difference to the roundabouts in Washington County and in Richfield, this also has overhead lane designation signs, which is different than the other ones. These are some screenshots of the video views that we collected. So basically, because we couldn't collect, again, the circular way, and because we're developing an automated way of extracting violations, we're collecting video from regular cameras, multiple regular cameras around the roundabout. Now, the 2 roundabouts in Mankato are, as I said, both on Highway 22. And the first one is the intersection with Adams Street as you go from north to south. And the bigger one is the one with the intersection with Madison Avenue. The Madison Avenue is a complete 2x2 with channelized right turns. So this is an additional new element to all the previous ones. And the Adams one has two 2x2 approaches and one sort of turbo roundabout additional lane opening on the south side of it. Now, the Mankato roundabouts also implemented very clear overhead signs, and but you don't see, and if you proceed further down, there is more signs that are actually mentioning the street names where each lane is going to take you. We had a very good collaboration with District 7 of MnDOT that were very engaged with the project. They provided us with amazing help. They brought power to the poles. They had their own crews helping us putting our cameras. So we basically managed to collect data from the first day the roundabout was opened and for several months after that. Now, changes in the signs and lane markings took place a year after the opening because of the observation of several mainly yield-related crashes. And we collected data after the new changes, which basically mostly involved the size and the location of the yield signs. Now, if you can see the video, you will see some examples of yield crash violations. Typical yield violations as the ones that Joe described earlier. Go to the next slide. Same, this is the Madison roundabout, and you see that the very heavy truck should have stopped, but it didn't. If you go to the next slide. Now, this is observations from the Adams roundabout, and basically two things are happening there. One is that there are yield violations, mainly on the north-south direction, and this is another yield violation where a very big semi-trailer. I cannot imagine what this trailer was thinking. Find the room to squeeze itself in the roundabout. Anyway, I'll see it again. Yeah, it's very peculiar, but this is a typical type of crashes that are happening in those two roundabouts. If you go to the next slide, now one additional conflict that has generated a few crashes, but is definitely a problem, is that, as I said, this roundabout has a semi-turbo roundabout design where an additional lane opens on the south only for left movement, but a lot of vehicles, mainly coming from Highway 22 southbound, they are confusing this lane and they're going straight, conflicting with the vehicles that are exiting on Adams. So the exit on Adams is a single lane, so two vehicles cannot fit side by side, so that is a potential problem for side swipes. And you see these vehicles that are performing the violation. If we go to the next slide, now, as I said, this is an example of our new technique of automatically extracting violations. In the Richfield roundabout project, because it was one roundabout, we employed a lot of students who hated us after the project because they had to watch every single vehicle going around the roundabout, thousands of vehicles. Now that we had 4 roundabouts, this was practically impossible. So we used open source code provided by a professor in the University of Montreal. And it basically allows us to extract trajectories of vehicles and set rules that will allow the computer to directly count the violations for us. So we can we can analyze a lot more video this way. If we go to the next slide. So the project at this point has collected all the data. Maybe we'll collect more if St. Cloud decides to implement any changes. The video analysis is underway, and we're basically going to have our results by the end of April. So we're very near completion for this project. So return back to Joe, who's going to talk about the current best practices that he's coming up with.
All right, thank you, John. As John mentioned, a lot of the positive results that they were seeing from some of these physical changes to the roundabout as far as improved signing, improved striping, seem to have a lot of effect on the turning violations, but not so much on the yielding violations. So I think what's really promising as far as direction for this research, now that this data can be collected and automated and aggregated at a much higher rate than before, it makes it much more practical for us to be able to do some effective before and after tests on some of these other treatments that we've started to employ that might be options for some other roundabouts around the state. So as I mentioned, the root of our problem, as we saw it, really boiled down to drivers were coming up with this mentality that they were making a right turn into the roundabout. That wasn't the case, but what they were seeing wasn't really enough to convince them otherwise. So what we wanted to focus on was designing the actual physical roundabout and the signing and striping to reduce those crashes. First of all, we wanted to make those differences more obvious to drivers. We wanted to have a consistent message for education, so any of our comments to the media, any of our instruction materials that we put on our website was all focused on that same consistent theme that a roundabout is not a right turn. And of course, we wanted to design to minimize those crash opportunities. So we want to do everything we can from both the signing and striping, the education, and the geometric design to do whatever we can to prevent that circle road misconception, that right turn misconception. And so as far as making the differences more obvious to drivers, we've deployed a number of tools at some of the roundabouts that we've been building. In large part from the outcome from Richfield and certainly from our own experience as well, we did eliminate usage of the fishhook signs at all of our roundabouts on county roads within the county. We did originally have some of these out at Radio and Bailey, and the reason these fell out of favor is because the shape of that arrow does imply, or certainly leave room for confusion, to suggest that entering the roundabout is a right turn, followed by some circulation, followed by another right turn to exit, which is really not what it ever was. You can see in the picture here that our exits are designed very much as a straight through movement. So eliminated the fishhook signs both on the signs and the pavement markings as well, and switched to the standard arrow. This was in large part informed by the research in Richfield. Also informed by the research in Richfield, we've adopted the solid lines on approaches. Usually, in most cases, we'd only use solid lines for an exclusive turn. Both of these are option lanes in that they both allow both turns and through movements, but there is some definite lane choice required. So you can see highlighted by the green line here, which is photoshopped in there, extending that solid line back from the entry point. We also used the strong skip marking. This was based on a suggestion that was published in NCHRP report 672. What we used to have and what we had, if I could go back slides easily, I could show you, but originally it was a solid line followed by kind of a light skip line, followed by another solid line, and then back to the broken line as you exit. And we've certainly been fond of using, since that time, using what we call the strong skip, which is indicated here by the blue bubble. And really what we're trying to do is for the drivers that are using this picture in the position of the school bus or next to where the school bus is, really create that visual cue that exiting is a straight through movement and that circulating is the left turn movement. Again, to reinforce that, we've been focusing a lot and really put a lot of effort into targeting these properly with each project, is a smooth edge line extension, really keeping it parallel to that strong skip mark that you see, just one lane width off of there. What you'll see at a lot of roundabouts is a lot of times this line will be shunted or it'll be set further back with the intention of having it do double duty as both an edge line extension and a yield line. This edge line extension is intended to keep drivers from striking the curb as they exit. It is not intended to be a yield line for approaching traffic. It's certainly important that they see it, but it's really not the same thing. And so it's important not to confuse these two. We also moved our pavement arrows forward. We used to put these directly across from the entrance point, and some of the feedback we were hearing was that it really wasn't enforcing that idea that exiting is a through movement. It allowed people to misconstrue forward as meaning around. And so painting that through arrow in the right-hand lane, if we put it further back, it really wasn't pointing out of the intersection at all. And so we moved these forward. Also helped to make it more visible to drivers that might be entering who would be seeing that arrow from the side. We've also implemented what we've called the ghost lane line. On almost all of our projects that involve new pavement, we have been grinding in our markings. This has some safety benefits, also some maintenance benefits as far as protecting the stripe from the plow. Since we have these crews out there doing this grinding anyway, we've been having them grind in essentially a false pavement joint on our bituminous roundabouts. And in the next slide here, I'll show you at a single lane roundabout what that looks like. You can see that they ran that grinding machine right across the left side edge of that through vehicle path. And I want to stress this is not a pavement marking. This is not a traffic control device, but it is a strong visual cue. Now what you'll also see in this same picture here is when the contractor paved this, they paved it in a concentric manner. Unfortunately, that's also a strong visual cue, but very much of the opposite type from what we would like to convey. You can see here our edge line extension is perfectly aligned with the solid 4-inch stripes on either side. This really turned out well as far as striping, but unfortunately that pavement joint is going to continue to show up and give the wrong impression to drivers. We did compile all of these best practices into a county striping detail sheet. This is much more detailed than what you will see in the METCD or in any standard plates. This is really getting down to the nitty-gritty of where do these things line up with respect to the curb faces, with respect to the travel paths, and so forth. This particular drawing is for a what we would call a 1x2 roundabout, where we have 2 through lanes crossing 1 through lane from the 90-degree approach. Jumping back to that original list, we want to have a consistent message to users, particularly through our education and media outreach. We want to be careful never to describe entry and exits as right turns. I will admit I was guilty of doing that as recently as about 10 years ago. There are newspaper articles to prove it, but fortunately I've learned as I go along that that's bad advice to give. We stopped using the fishhook arrows for the same reason. They imply right turns. We also would never tell a driver to use a right turn signal to exit a roundabout. Again, that's a through movement. We don't want to create that impression that it's a right turn. We also want to ensure, as I mentioned, that pavement joints reinforce the stripes, so if something is paved concentrically, whether it's a concrete roundabout or a bituminous roundabout, having that joint cut across the exit really conveys the wrong message to drivers, especially in the rain when the pavement markings aren't quite as visible. And we want to avoid any references to the circle or circulating traffic. Each of these are misleading when it comes to modern roundabouts. And of course, we also want to minimize crash opportunities. Wherever we can, we don't want to provide the potential for this type of crash to happen, because if that potential is there, a certain number of drivers will avail themselves of that opportunity. So we've been doing what we can to avoid these 2x2 configurations. We had originally designed for a 20-year volume, which really isn't a bad thing in non-roundabout context, but just creates some of those opportunities for mistakes. So it's better to design it for future expansion, make it easy on yourself to expand it in the future, but don't build it all now if you don't need to. One way to possibly do this, which has not yet been done in this state, but has been done down in Florida with some success, is to consider installing a metering signal. Sometimes this can be done on just one approach. It can be implemented just during the peak hour and can help you get the benefits of the roundabout 24 hours a day while still managing those peak hour issues. As far as reducing those opportunities, we implemented what we had called the roundabout diet. This is the before condition at Radio and Bailey and Woodbury. You can see there were 2 through lanes in both directions. What you can't see in this picture is at the top of the picture and at the bottom, this picture is looking west. The road dropped back down to a 2-lane rural design. So as you would come into the roundabout, it would become a 4-lane road, and then it would drop right back down to a 2-lane road as you exited. This was really making a lot of those crashes possible for capacity that really wasn't needed under today's volumes. This is a Photoshop mock-up that we created for media usage and for sharing with elected officials, showing what we intended to do. So you can see between the original version, the before condition here, and the after version, what we did is we eliminated the second lane for the eastbound and westbound movements. And in doing that, we really prevented a lot of the types of crashes that were happening. First of all, the failure to yield crashes, we improved yielding compliance on the approaches by dispelling this false notion of an inner ring and an outer ring. There never was an inner ring and an outer ring, but we know that certain drivers perceived it that way. So doing this helped eliminate that attempt to merge alongside traffic. We certainly never wanted anyone to merge. It was always a yield condition, but we wanted to do what we could to prevent that. Likewise, we also prevented the improper turn crashes. Even though we only did this on 2 sides, we physically prevented that improper outside left from all 4 directions, because we either made it impossible to turn to that location or impossible to make a left turn from that location. So that worked on all sides. Future areas of interest, especially now that this video collection is available, things that we would like to see tested with more academic rigor, are some of these things that we haven't tried yet. The current METCD standard sign, to me, really implies this concept of a circle road. The other images that you see on the right-hand side here came from this same publication in Canada that started asking a larger question of, is there a different type of warning sign that maybe could convey this a little bit differently and more effectively? Now, these are all, I know, kind of goofy designs. They would have to go through some human factors testing, but the existing sign design really isn't conveying the idea that we would like it to. As mentioned, we've already been using the ghost line, but it's really never been rigorously tested, either at a bituminous roundabout or at a concrete roundabout. We've also been focusing, especially since we've had some considerable success at our multi-lane roundabouts, eliminating these types of multi-lane crashes, also starting to focus a little bit more on the distracted driver and the unfamiliar driver that just come into the roundabout too fast. And certainly we want people to come in at a proper speed, regardless of if it's single lane or multi-lane. Some of the things we've started doing is installing these yellow tube delineators. This was largely an outgrowth of having to replace this left side yield sign that would get struck fairly often by vehicles, and really help, especially at night, help it jump out that drivers need to go to the right-hand side of that sign, not to the left-hand side, and help them realize that sooner. At one roundabout, we also installed a clearance marker. You can see we have this bank of chevrons in the middle that really helps the driver see that there's something in their path. But there's really very little guidance to help them know just how far over to the right they need to divert around that center island. And so in this case, we installed a clearance marker that was actually mounted at 90 degrees to the next bank of chevrons. Certainly what we were seeing from these crashes for the distracted, drowsy, intoxicated drivers, they weren't hitting the chevrons that were facing them, they were hitting the chevrons that were off to their right, facing that approach. So we wanted to help make that a little bit more visible. These are certainly things we'd like to see tested for future research to see, does it have an effect on speed in particular. Similarly, another way to treat that might be to look at spacing out the chevrons. This is an actual picture showing our normal bank of 4 chevrons, but maybe we ought to consider spacing those out to really help drivers perceive just how far they need to go off to the right. Even in a multi-lane condition, we certainly want to help control approach speeds. Hopefully, if drivers come in at a more reasonable speed, they'll have a little bit more time to think critically about what they're doing, and that's always a good thing for safety. John also mentioned the overhead signs being used down in Lakeville, certainly something that is intended to address that lane use issue more than the yielding issue. But a lot of roundabouts don't have these, and particularly for roundabouts that are having those lane use crashes, this is certainly something that it would be great to have some data on. Are these sufficiently effective at reducing those types of crashes? That is the end of my presentation. Looks like we have about 9 minutes left for questions. I'm certainly able to stick around a little bit longer as long as the connection stays live. So thank you all for listening.
Thanks, John and Joe, for your great presentation. And we do, as Joe mentioned, we do have some time for questions. And I do have one submitted right now, so I'll just speak that, and John and Joe, both of you can take it, or one of you, or however you want to work that. So Carol Keys asks, the design of roundabouts, is there consideration for how the medians and center will be safely maintained?
I'll take a stab at that one. The medians on the approaches to our roundabouts really don't have much in the way of maintenance needs, with the exception of clearing snow out of the crosswalks. That is sometimes a challenge. Our cities that plow those trails tend to do so with a pickup mounted plow, and so they have trouble negotiating through some of these narrow median passages if they're not designed to accommodate that type of plowing. But I assume that the question is primarily related to maintenance within the center island. We allow that type of maintenance and that landscaping under permit from the local cities. We don't conduct it ourselves. With that, we require really just the standard types of work zone apparel and so forth. We do not allow them to block lanes within the roundabout except by a separate permit. We do have a set of, in the event that a lane does need to be closed within the roundabout, and we have had to do this when we do striping work within the roundabout, when we need to shut down a lane or two. We do have a set of layouts that we developed for that, that sometimes closes off an entire quadrant of the roundabout, forces everybody to make a right turn and U-turn to come back to the roundabout, some location downstream. So it's not something that's been a big problem. I'm not sure if I fully answered the question, but certainly that landscaping in the middle is definitely one of the big selling points for the community, so we want to find a way be as flexible as we can to accommodate that.
Great. I don't have any other questions submitted quite yet, but we can give everybody a couple minutes. Please feel free to type them either in the chat box or in the Q&A panel below. All right. So if we don't have any other questions, I'm going to turn it over to Professor Max Jonas to close us out.
Thank you for joining us for the second webinar of the Transportation Safety Webinar Series. Please join us again on Tuesday, April 19th for a presentation from Shauna Hallmark at Iowa State University and Lee Bierke, County Engineer at Winneshiek County in Iowa, to learn about their topic, Evaluation of Low-Cost Traffic Calming for Rural Communities. Thanks again for joining us today.
All right, and I actually did get a question submitted, so even though Max closed this out, I do want to have a chance for the speakers to respond to that. So Ryan Crum asks, what is the current thinking in regards to visual barriers inside the RAB that prevent seeing across? Our engineers always say we don't want folks looking across the RAB, only looking to the left. Police departments feel differently?
I think that the prevailing engineering opinion is that we don't like to have folks looking across the island, so they can actually looking only to their left for the vehicles that are coming. That's why there's now there's some debate as to the amount of obstruction that people are putting. There's in some roundabouts, not in Minnesota, they put whole sculptures and big walls in the middle of the roundabout. But in Minnesota, we generally just raise the amount to the higher level than the car and do landscaping. I don't know if Joe has anything to add to that.
Yeah, I'll take a stab at that one as well. Where we've had that discussion, it's been primarily centered around the pedestrian crosswalks. It has not really been coming from the police department in our locations, but we'll hear sometimes from pedestrians that they wish they could have a little bit more advance notice of being able to see when cars are approaching, so that they can make a decision as to whether or not they want to choose to enter the crosswalk at that point. We have conducted some fairly extensive studies on that at one of our roundabouts. We found that the time that was available to see a car that would, for example, be making a left turn around the center island and then exiting towards that crosswalk. The sight distance available was in the range of 5 to 6 seconds, and that's not enough time to get across the entire crosswalk for most, or well, for some people. Some certainly could. But it is absolutely, definitely enough time for that car to come to a safe stop and to yield to that crosswalk user. So that's what it's focused on for us. But generally, we would concur with the prevailing engineering thinking that for drivers, we really don't want them seeing across to the other side. We want them focused exclusively on the traffic that is coming from their left as they approach, and for the crosswalks as they approach and exit. And we've made sure that we have the adequate sight distance for drivers to make safe decisions in those situations.
Great. I have one final question here. Amy Stearns asks, is there testing going on at the University of Minnesota or elsewhere on how autonomous vehicles will handle roundabouts?
Well, no, for the University of Minnesota, I know for sure that we don't have any such testing, but I've seen test drives of autonomous vehicles from the University of Parma in Italy that have been handling roundabouts quite well. So they basically follow the same rules that the regular drivers should follow.
Great. Well, thanks everyone. Oh, sorry, go ahead, Joe.
No, I was going to say I'll add to that. As far as one of the pioneering firms of autonomous vehicles within this country, also is a very big web company that I won't name, but curiously, their mapping protocol always requires that all roundabouts and also traffic circles all be mapped as traffic circles. For some reason, their policy and practices insist on mapping modern roundabouts as a series of T intersections, even though when it's very clear from the aerial photos that they're anything but. If they start integrating that map data with their autonomous vehicle projects, which I assume is a natural expectation as projects move forward, I really think they're going to have a hard time reconciling that. So certainly a first step would be to get good, solid, correct map data, make sure that the mapping software that the autonomous vehicles are following, that if they are GIS-based, are actually based on the right information, in that a roundabout is not a series of T intersections.
All right, thanks everybody for joining us, and as Max said, please do remember to come back again on Tuesday, April 19th. Thanks everyone.